Welcome everyone to my talk about platform building for a data mesh, in which I will try to show you how we at ACA Group are tackling this problem. I'm Tom de Wolf. I have experience about 15 years or more in IT industry, mostly from a software engineering background and architecture role. What I have in store for the next small hour is first a very quick intro to data mesh, and then go into a high-level overview of what the different components are we see that are needed in a data mesh solution, and then go to the core of the presentation to show you how we've built a platform for data products, goes into some mesh-wide capabilities, and then ends with some guidelines and a summary. So quick intro, data mesh. If you look at a traditional approach, let's try to paint the picture of that. Let's take an example of a e-commerce company, in which maybe try to zoom in a bit. So in which we have a product information system, for example, shopping cart service, CRM system, order fulfillment services, a number of applications. And on the other hand, we have the business intelligence system and other systems that need the typical analytical insights. And what typically is done is to build the necessary end-to-end data pipelines, which take the data from the source systems, clean it, structure it, and get it ready for a specific report in the BI system. And for each use case, different pipelines are developed and created in a more central approach and central architecture in a data warehouse, a data lake, or something like that. Also, some structure is put upon it in the typical layers, like a bronze, silver, golden layer, to get that data cleaned and ready for use. So as I said, this is more a centralized structure and also a centralized ownership. So it's typically a central data team or a data business unit that's responsible for realizing all these data requirements. And when you look at this structure, it's also more a technically aligned structure. So what data mesh does is to really talk about a decentralized structure, to do a decomposition of the data, and also really think about reusability of data as a product. So next to the applications, we're also going to have data products, which have the goal to make the data from source systems or other data products easily reusable for different analytical use cases. Now, if we put some colors on it, and the colors represent the different business domains in which these applications and/or data products belong, then we can also talk about a decentralized ownership of these data products. It will no longer be the central data team that needs to take ownership of all the data products in that data mesh, but together with the applications that are owned by the business domain teams, also the data products will become the responsibility of those teams to make that data easily reusable for analytical purposes and other use cases. All this to avoid that data team to become a bottleneck in the face of growth, and to keep that business agility that companies want when they want to go fast and respond to market changes. So basically, data products decompose data similar to how microservices decompose application landscapes. And same thing like microservices, we put them into the business domains for ownership. Also, the data products are put in those domains, and they're owned by a cross-functional team, which is now composed not only in software and business people, but also data expertise is included in them. Data mesh also provides 4 guiding principles for every solution, but the one we're focusing on today is the one of the self-service data mesh platform. The other principles do put some requirements on that platform. So for example, if you want to enable decentralized domain ownership, then you have to make sure that the platform puts enough self-service tooling in the hands of those developers so that those teams can autonomously share the data they own. Data as a product means that the component of a data product really has to be a first-class abstraction, a first-class component in that platform, and that platform has to support the life cycle of that data product. And concerning data governance, when there are policies decided upon, we want the platform to automate them as much as possible. So that is a quick intro to data mesh. Now let's go into the platform as a whole. Which components do we see for a self-service platform? First thing to notice is that there are a lot of data technologies around. So we have the typical data warehouses, data lake technologies like Amazon S3, cloud storage. You have streaming technologies like Kafka, time series databases. Any type of data structure is supported with the data storage technology, but also query engines, and of course the compute, the data pipeline technologies are available in the community. Consider all these technologies to be present in what's called the utility plane, so all the infrastructure and enabling technology. And a data engineer once told me, as data engineers and scientists, we often forget the complexity of the tools we use. And on the other hand, we want to make sure with data mesh that any software engineering team has the capability to share and reuse the data without being that expert data engineer. So what we want to do is to put a layer on top that introduces that abstraction of a data product, with the goal to make that data product developer experience as smooth as possible, and to abstract away all the unnecessary complexity of the tools and the data tools that you want to use. So that data product experience plane, sort of say, is the self-service layer, which allows that data product developer to define the data product, develop it using some kind of development kit, deploy and build it. If we zoom out a little bit more, then we're not only talking about the data product developer anymore, but also about the consumer of the data of the consumer, or the consumer of the data products. And for that, some more mesh-wide capabilities are needed, like, for example, the ability to discover which data products are present in the data mesh, to know which ones are interesting for the use case they want to solve. But also things like lineage and observability, they all belong in that conceptual layer. And of course, on top of that platform, we want to enable all the use cases and applications that are going to use the data, which can be the typical BI systems, but also AI and machine learning use cases and end-user applications that want to feed in that data again. So this is as a high-level overview. In the next section, I'm going to dive into the middle two layers of that platform. And the first is to notice that for a data mesh platform, it's all about building a platform for data products, sharing and reusing data as a product. And that's where we need some platform engineering and abstraction building to really automate and orchestrate everything that's needed for creating a data product, encapsulate that accidental complexity, and really lower the cognitive load of a data product developer, so he has a very simple self-service experience. And why is that important? Because when it's easy to do that, when it's fast to do that, then we can also get that business agility with respect to data, and keep that when we're growing and changing things. So how we're going to build such a platform? Well, a high-level pattern often seen is that the platform solution is conceptually composed of, on the one hand, a control plane, which focuses on the platform orchestration and contains all the intelligence and automation. And on the other hand, the data plane, which focuses on executing the components, in our case, the data products. We're using Kubernetes as sort of a universal control plane, a framework for building platforms, a framework for building control planes. So we're targeting at cloud-native platform engineering, and we're really going to build an API for data products. As I said, the components in that data mesh are the data products and the technologies we use for them. And we want to automate and orchestrate every part of what a data product contains and needs. Now, what is it? The anatomy of such a data product, and to what do we want to raise our abstraction level? You can consider the data product as being the independently deployable component of that platform. So it has a high functional cohesion. For example, in the e-commerce example, all data of shipments of orders will be the responsibility of one data product, which will make the data of those order shipments reusable in different formats towards the use cases. Of course, that means that the data product needs to get the data somewhere. So there are some input ports, can be database connections, can be using APIs or other types of input. And of course, the output ports, which are the important thing of a data product, where the same data is made available in different data formats, in different data access protocols, different data technologies, which are targeted at specific use cases for which they are optimally chosen. Each of those output ports also needs to be addressable. It needs to be easy to, from the external world, consume data from a specific output of a specific data product on that platform. So some kind of URL solution to address a specific data product is needed there. Of course, the data product contains the transformation logic that takes the input, transforms the data, and writes it to the different outputs. And next to the data, a data product also contains the metadata of that data product. On the one hand, is a specification of the structure we're describing here, but on the other hand, it's also self-describing metadata, which actually more documents the data product, documents what data it contains, for which types of business it's useful, and things like that. If you go further, you could say that there are a number of other ports on a data product, some for observability, outputting metrics, logs, anything from what's happening in that data product. Another one is a discovery port. So all the metadata is made available for discovery towards a data discovery catalog, so that consumers can find which data is present on the platform. And finally, a control port, which allows the platform itself to interact with the data product, configure it, trigger it for execution when it's needed, and things like that. One important type of input port is, of course, the one where a data product will consume data from another upstream data product. So that's where the different data products can connect to each other, form that network, and form that data mesh, which the style of architecture is talking about. Okay, how can we build this abstraction? This first an example maybe. So this is for the order shipments, data product about order shipments, which connects to the order fulfillment service, for example, through a MySQL database connection, and which will contain a simple data transformer written in Python, which runs as, for example, a simple container job. That could be the simplest possible transformation technology that you use. Of course, the metadata, which we'll come back to later, and then the different types of output ports. For example, one is for a use case in BI and reporting, where tabular information is more suited. So there we can use the data warehouse technologies, like, for example, ClickHouse or BigQuery or other types of tech. When we have bulk files like images, videos, and things like that to do pattern matching on for machine learning, then more data lake type technologies are more suited. Use cases that require real-time decision making, require streaming technologies, and maybe some specific APIs, for example, for linked data, could make use of what's called triple stores to expose the data like that. Building the data product abstraction in Kubernetes. So what does it mean to create APIs in Kubernetes? In Kubernetes, an API is what's called a resource. It's kind of a document in which a specification is put of what the desired state of a certain resource is. And what we can do is, of course, to create a data product resource, a custom resource, which contains the version, kind, the type of the resource, some metadata. And in the spec, it defines the metadata of the data product, summary to which domain it belongs, maybe some information about the terms of use, information about the ownership, who has the business ownership of that data product, who is technically responsible, and then some more specification about which type of transformation it uses. In this example, a simple one using a container, which is scheduled on this cron expression. And then information about the input ports and the output ports. And this is the example of the order fulfillment service with the database connection. And of course, in the output port section, we have the different types. One which contains the raw shipment files in a blob store, and another one which contains the analytical data in a tabular format, including, for example, a column definition of which structure is to be expected there. So this is a declarative API that expresses that desired state, and using that API is inspecting those resources, manipulating them, and that can be done with the default tools that any other Kubernetes resource is inspected with. And the more default ones are a deployment, a pod, and other things like that. But of course, you can define then your own, like this data product. Apply a data product to the environment on which the platform can go and do things, inspect which data products are running, when they were last updated, which gives information about the freshness of the data. And in general, all these custom resources are actually also REST endpoints and a real API which can be used. Of course, the data product is more than the data set. It's also about automating and provisioning all the CI/CD pipelines needed to build and deploy it, the different data storage technologies to support the output ports, provide the compute that's needed, possibly some security credentials and secrets. So we also want to go and orchestrate things and automate things. And what's that in Kubernetes? Well, that's also all following a certain pattern. So the developer can use CLI tools, APIs, or user interfaces to manipulate those resources through an API server in Kubernetes. And then asynchronous processes, which are called operators, take that state, watch those resources, and try to reflect the desired state into the data plane, into the environment, so that it really reconciles that state in your platform. And this is called the operator pattern. And an operator is nothing more than a container running in Kubernetes, so it can be written in any language. For example, in Java, there's the Java operator SDK, which can be used to write such things. And its job is to really solve the delta between the actual and the desired state. Do notice that this data plane doesn't have to be only Kubernetes containers or things running in Kubernetes. It can be anything outside of Kubernetes too. So the more data as a service tools of the vendors can be orchestrated using this pattern. So what we'll end up with is a data mesh control plane driven by those operators, and on which we're going to define a number of custom resources that are our abstractions which we want to make available to the data product developers. And in the data plane, there can be things like, for example, BigQuery as a data warehouse, or other types of more function-like execution environments, or anything really that has an API and can be orchestrated with that. What we want to do with that is enable the life cycle of the data product and actually the development life cycle of a data product developer. You will start with registering new data products, and then the platform can take over and bootstrap everything that's needed to make that happen, which makes it possible for the developer to start developing the data product, make it build and deploy on the platform, and eventually run on it. And when we go further, the consumer wants to discover those data products, explore the data in it, and actually consume it for their use case. So let's first focus on the registration phase. So a data product developer wants to create a new data product. Suppose he has some kind of user interface for this, in which he can enter that metadata about the data product, so the name, the domain it's in, some describing information, some information about the ownership, but also a choice of which type of transformer he will write. Will it be a simple data transformation written in a Java container or a Python container, or maybe a more advanced data pipeline technology which he wants to use? And from that, we can then generate that custom resource in the Kubernetes environment. In this case, it's called the data product registration resource, which is just to cover the registration part. It will only contain that descriptive information, the selections he has made in the user interface. To explain what happens then, I'm going to use images like this. So we have the control plane in gray on the left and the data plane, what will be automated or orchestrated on the right. We have the application that I showed earlier. And the data product registration custom resource is the API on which he is going to apply it. And then an operator, in this case it was a Java process written in Micronaut, will take over and apply all the logic needed. There are a number of things that are happening on bootstrapping a data product. One thing is, when it doesn't exist yet, delineate or segmenting something in the environment that represents the business domain where that data product belongs to. In this case, it was a Kubernetes namespace in which those jobs could run, and some credentials to access Git and Docker registry that were provisioned there. More importantly, it will generate a new code repository in Git that is specifically for that data product. And it will be generated based on a template and based on what selection he has made on the type of transformation he wants to write. And then two other parts are about continuous integration and deployment. So everything is put in place, some webhooks or some mechanisms to make sure that when something is committed by the data product developer, that data product is built and is eventually deployed on the environment. So if that is provisioned, then the data product developer can start developing his data product. So we will use that generated code repository. This is an example of an outline of quite a default Python project, but it also contains the metadata. That's the data product.yaml file here, which is that custom resource we defined in Kubernetes. That's the abstraction against which he is going to develop. He will write the transformation codes, which will then connect to the inputs, write to the outputs, and do the transformation that's needed. And of course, the data will flow through from the in to the output. Okay, once the development is done or a first version is ready, we want to build, deploy, and provision that. So we have, on the one hand, a custom resource being that data product with all the specifications in it. And again, here, I'll go into detail in the next slides, but we have a design of a control plane and a data plane realizing this. One pattern we see here is Kubernetes resources and operators are also a composable mechanism in which we can define resources for low-level components, build upon them, and in that way really design our control plane in a good way. And the first layer is it takes the data product custom resource and it will split that up in different concerns. And there are two groups. One is about the output ports and the different types we support. I'll also zoom into that a bit. So for example, we support analytical data in an output port, blob store, and linked data in an output port. And for that, the operator does nothing more than convert that to more specific resources that represent those output ports and take over the metadata which is relevant for realizing that output port. Same thing is for the transformation. So we could have, for example, two types, a simple and an advanced one. And also for that, the resources that are needed for that are created. And then the platform takes over to have an operator for each of those sub-resources. So for example, if we take for the output ports, the blob store output port, which is targeted at AI and machine learning use cases when images and videos are part of the data, the first thing it will do is to provision part, in this case on Amazon S3, an S3 bucket, which will make it possible for the transformation logic to write the data into that S3 bucket. And this is actually a common pattern that you should see when implementing a data mesh approach. And you have those different data products, they all need their parts. For example, if you have two data products which each have an output port which is realized in a data lake technology, then it should be possible in that data lake to really define the boundaries around that output port, around that data product, to make sure that each data product has its own segment, its own sandbox, so that they cannot conflict with each other. So in general, also any data technology that allows you to do that, to really define the segments that you can map on your data products, is the preferred choice. So once that is done, another thing that the operator does is to provide that URL for addressability. So in the example here below, base URL, and it includes things like the domain name, the data product name, and also the name of the output port, making it possible to consume the data from that output port from other data products or from the outside. For this, we've used Istio Virtual Services to make that mapping happen. And the same thing happens for the other types of output ports which we represent. In this case, analytical data is realized with ClickHouse data warehouse technology, and the linked data with a triple store. And what's nice to see here is that we've tried to design the platform that it's pluggable, so that we can add new types of output ports when new use cases come along that require another type of data technology to be integrated, and you want to provide the data product developer an easy way to use it. So this is where data mesh really complements existing data tech. So it's not about replacing all the existing technologies. It's really about using them for the right use case and making sure that they are pluggable in your data mesh platform. Of which these are the examples. So for output port types, the data lakes, data warehouses, streaming, time series databases, and other types of storage are suitable. Input ports could be just database connections or more complex ingest technology that exists. And for the data transformer types, you can have the simple compute of a container job, but also leverage the data pipeline tech like Google Dataflow or more workflow technology like Apache Airflow. Same thing for the transformer. The simple transformer operator will just manage and run the code that was built as a job on Kubernetes and make sure that that transformation takes the input and writes it to the output. And an advanced one can use the API of Google Dataflow in this example to do the same, to deploy and run the Dataflow pipeline code on GCP. And that way also for this, that is made pluggable. All this to illustrate that a lot of things are needed for one data product, and you don't want to bother a data product developer with every detail that's going on. So we want to replace this with that abstraction, with the ability to define what the data product developer has in mind in a declarative way, in a specification, which the platform then uses to automate everything and make sure that the data product developer can just focus on writing the transformation logic. Okay, so we have capabilities for supporting data products. Now some mesh-wide capabilities, which is of the image of the layers earlier, the data mesh experience plane. And one is the data discovery catalog. So we want to have an ability to search and find the different data products that are present, This is an example of Data Hub, which is an open source project. We have adapted it a bit to include data products as an abstraction, but one of the next releases will also include it in the open source project. And of course, next to searching it, you can get the detailed information about what the data product is. And here you will see all the meta information that was entered by the data product developer again, so that a consumer of data can see here what the data is about, who owns it, what the output ports are, and which data sets are available in which formats to consume. And also information about lineage can be made available in these kind of tools. Also, this is implemented with an operator, data discovery operator, also runs in Kubernetes, and the only thing it does is to watch all the resources that we define in the platform and feed the metadata and status information towards the data product catalog so that it is visualized and available for discovery. And a last, more mesh-wide capability I want to illustrate is something of an eventing backbone. What's the problem? When you have a mesh, a network with different data products, each working on their own life cycle, getting new versions, things like that, and they're connected with each other. When, for example, a data product on a source system gets updated and gets a new version of the data, you of course want to have the whole network of data products being up to date as fast as possible so that you can have fresh data in your data mesh. And the pattern we're going to use is to make sure that every data product will actually subscribe to an upstream data product for changes that happen there. And when that happens, run its own transformation. And that's also something that a data mesh platform can take away from the data product developer and orchestrate in the back end. And we do that in an event-based way. So let's take an example, data mesh. We have some source systems on the left and some data products that only consume those, and then other data products more downstream that build upon that. So what we've done, and I'll zoom in a bit for that too. For the data products that only consume from source systems, there we want some kind of batch scheduling. And we've used Knative, which allows, as a cloud-native technology, which allows to define some kind of scheduler, and it will emit for each data product that's scheduled based on the cron expression a scheduled event to say, okay, you can schedule yourself. That's converted into a command to transform that data product, and when that one is finished, so for example, this Saturnus data product, a new cloud event will be emitted to say, oh, I was updated, which is then taken by downstream data products to be converted into a transform command for their own. And this is what then happens throughout the mesh, which means that that way the data mesh keeps itself up to date as fast as possible. Responsibility of implementing this, reacting to the different domain events is also a transformer, an operator that is responsible for this, and that runs in the control plane of that data mesh. Okay, to wrap up, some guidelines and a quick summary. So, as I said, data mesh is not about replacing existing data technologies, it's about making it possible to integrate them and consider them as plugins for input port types, output port types, transformation types, things like that, to really give you a certain flexibility in your data platform to leveraging the right data technology for the use case, the data use case and requirements that you have. Also prefer choosing data technologies and tools which are open enough to be orchestrated from the outside, so which at least have an API. If that's not the case, it will be quite hard to make it integrate in this model. Also prefer data technologies in which you see at least the ability to define the boundary around that segment of where the data is that is owned by a data product, so that you can really enforce those boundaries and also, for example, put security policies on them for data accessibility and things like that. try to keep the core platform layer generic across all those data technologies and vendor tools. For example, that core data product abstraction and the lifecycle orchestration, we've put that in a Kubernetes platform to make it runnable on almost any environment. And also the discovery mechanism of the data catalog is there, all to avoid the need to rebuild or swap out the data platform for a whole new data platform when a new requirement comes along or a new technology comes along. Also start small and simple. And the intention of data mesh is to make every domain team able to share and reuse data. So at least make it as simple as possible for a more generic developer to also have the ability to do that. For example, by providing the ability to just write some Java or Python code to do the transformations, and that it runs in a simple container or in a simple cloud function, if that means the same thing. And then provide the more complex technology as an additional option, as a choice. So that when a data engineer that has more experience, or when a use case comes along that needs to process more and more data and has advanced processing, that also these options are available, and that, for example, they can then start writing their Google data flow pipelines instead. So building a data mesh platform, we've used the option of cloud-native platform engineering in that Kubernetes control plane. It really allows you to build that data product abstraction and automate the lifecycle of it. And building upon that, you can have those mesh-wide capabilities for data discovery, lineage, and that event-based execution pattern. All that to enable that decentralized ownership of those data products and enable thinking about data as a product you can share in itself, independently of a report or a dashboard that's created, but really think about reusability of data. And that with that self-service platform as a key capability. So that's my presentation, and I think we still have 10 minutes or so for possible questions. Any questions? If not, and if you think of one later, use my email or Twitter handle to let me know also of any feedback you have on this presentation. And with that, thank you for listening.